Hello. Hello. This is the third week Kahoot challenge. Hello. So today we will revise the second week's lesson by playing a game about electron configuration of atoms and ions and the periodic trends. Okay, let's go. So before playing this game, you should have a periodic table next to you. And the first question is about which one has 8 valence electrons. And we have sodium plus krypton, chlorine. So now let's take a look. Krypton, it is a noble gas and it is in the 8A group. So it has 8 valence electrons. There is a way to determine very quickly the number of valence electrons for any atoms is using the number of the group. So for krypton, it is in 8 group. So it has 8 valence electrons. For example, for chlorine, it is in the 7A group. So it will have 7 valence electrons. The same will be for transition metals. For chromium, for example, its configuration is, you can see that it is in the 6th group, 6B. So it will have 6 valence electrons. And remember that for transition metals, the valence electrons are the outmost shell plus the unformed D subshell. So we have for chromium, we have 1 electrons in the outermost shell, and there are 5 electrons in the unformed D subshell. So totally it has 6 valence electrons. How about chlorine minus? Chlorine has 7 valence electrons, and after receiving 1 electron to become chlorine minus, it has 8 valence electrons. And the same for potassium plus. We know that potassium has 1 valence electrons, and after losing this electron, it will have the configuration of argon, which has 8 valence electrons. So the correct answer here is all of these. Sodium plus, krypton, and chlorine minus have 8 valence electrons. Okay, 3D4. For we have potassium plus here. A potassium plus, potassium has 1 valence electrons, and after losing 1 electron, it will have the configuration of argon, which is a 3. This is not so, is not the one in the question. The second is iron 3 plus. For iron, we have 4. We have for iron 4s2 3d6. After losing 3, when we take away 3 electrons, the first 2 is from 4s2 and the third electron is from this subshell. So the configuration of iron 3 plus will be 3d5. So it's not correct. For vanadium 3 plus, here is vanadium. So taking away 3 electrons, the first 2 is these 2 electrons, and the third electron is from this subshell. So the remaining electron for vanadium 3 plus will be 3d2. So the next one is chromium 2 plus. After losing the first electron here and the second electron from this subshell, we have 3d4. So in this question, chromium 2 plus is correct. Okay, for iron 2 plus, so this is the configuration of iron. So we take 2 electrons from it. It will be from the 4s2 subshell, and the remaining will be 3d6, and the core electron will be that of argon. So it will be argon here. Correct answer. In the ground state, so we can see that. Let's take a look at this first one. 1s2 and 2s2 is not correct because these two electrons have the same spin, is not obeying the Pauli exclusion principle, so it's not correct. For this configuration, we can see 1s1 and 2s2 is not correct because it is not the ground state, because for ground state 1s subshell must be full first, and after that will be 2s. So this is in fact excited state. In Vietnamese, trạng thái kích thích, and the ground state is trạng thái nền, trạng thái cơ bản. And this configuration is not correct because we have 2 electrons here in the same orbital. So it's not obeying the Hund's rule. And the correct one is this question, is this answer. One thing you should note here is in many textbooks, you will see that this electron, in fact, is written here, up. But this is also correct. It's just a convention that we write electrons from left to right. So the 5th electron here and the next one usually is written here. But remember that these 3 orbitals have the same energy. So the last electron can be here or here. They are the same. They have the same energy, the same stability. Uh, the difference between these 3 orbitals is the orientation in space, and they have the same energy. So this is correct also. Okay, negative electron affinity. Ái lực điện tử âm. So you can see here, these 5 electron configurations have, they are in the 3rd period. You can see that the biggest quantum number, principal quantum number is 3. So in the same period, this one is 1A. This is 2A group. This is 3A. This is 6A, and this is 7A. So you can imagine that they are in the same row. In the periodic table, they are seen in the same row, and this is on the right side in the 7A. So this must be the one with the most negative electron affinity. You can see here 3 in the 3rd period. In fact, these are sodium, magnesium, and phosphorus, sulfur, and chlorine, I think. So the one with 7 valence electrons is in the right side of the period, so it will have the strongest electron affinity, or the most negative electron affinity. Okay, for oxygen atom, so remember that for oxygen, oxygen has this configuration, and the 2s2 is paired already. And for 2p4, imagine that you have 3 orbitals, and 4 electrons will be filled this way: 1, 2, 3, and 4. So 2 electrons are paired and 2 are unpaired. So the correct answer here is 2 unpaired electrons. So what is a Lewis symbol? Lewis symbol is, for example, for oxygen, you will have oxygen, and 6 electrons will be expressed by 6 dots. 1, 2, 3, 4, 5, 6. Okay. Okay. Isoelectronic. Remember that isoelectronic is having the same number of electrons. So we have argon and neon. Argon here and neon is here. So for neon, fluorine minus, so we can see that the fluorine is having 9 electrons. So fluorine minus, we have 10 electrons as neon, and chlorine is having 17. So receiving 1 electron, chlorine will have 18. So fluorine minus will be isoelectronic with neon, and chlorine minus is isoelectronic with argon. So argon is a chlorine minus and chlorine minus, and so the correct answer is here. This is a very easy. The question is about electron configuration of argon. Argon. So you can write it with even without the periodic table. You can write it. Um, but another way, if you remember, you can see that this is not correct because 2p10 for p subshell, it contains 3 orbitals, so maximum it contains only 6 electrons, so the red is not correct. This is also not correct because 2s4 is impossible because s orbital has only 2 electrons maximum. And this one is also not correct because you have 2s6. So of course the valid one is this, and is also the correct configuration of argon. Of course, you can use the periodic table to answer this. Azimuthal quantum number for the outermost electron in nitrogen. So for nitrogen, you can see here, nitrogen is 2s2 to p3, and the outermost subshell, outermost orbital is in p. So for p, secondary quantum number or azimuthal will be 1 because S is 0, P is 1, D is 2, F is 3. Okay, you can see that 4s2, 3d10, and 4p3. You can see that it is in the 4th period of the table, and it is in the 5a group because the outermost shell has 2 and 3 equal 5 electrons. So it is in the 4th period here, and in the 5a group it is arsenic. So arsenic isoelectronic series. So here you can see a calcium, potassium, argon, and chlorine. Chlorine, argon, potassium, and calcium. And so for isoelectronic ions, you can see they are ions with the same number of electrons. So they will have the same um, electron shells. So the difference is in their nuclear charge. And for isoelectronic ions, if the nuclear charge is higher, the attraction force between the nucleus and electrons could be stronger, and so the electrons could be pulled closer to the nucleus, and the radius will be smaller. So for calcium, this is the element with highest nuclear charge in this series. So calcium will be smallest, calcium 2 plus will be smallest, and then potassium plus, and then argon, and then chlorine minus, and the correct answer here is this one. Okay, it is about second ionization energy. Sodium, magnesium, aluminum, and silicon. You can see that they are sodium, magnesium here, aluminum, and silicon. They are in the same period. And and remember, the question is about the second largest ionization energy. So this element must have one valence electrons, because after losing the first one electron, the second electron will be the, in the inner shell. The second electron is the core electron. And so the correct answer here must be sodium. And of course, you can check a table in this textbook. So in this page, 330, is the successive ionization energy of elements. You can see that for sodium, I2 is about 4,000. It is higher than that of magnesium, aluminum, and silicon. The reason is the second electron of sodium is in the core shell, so it is very stable, and it has lower principal quantum number. Uh, it has a principal quantum number of the second electron for sodium is 2. The outer electron has n equals 3. And so n equals 2 will have much lower energy than the valence electron. So it's very hard to remove the second electron from sodium. Okay, we have 5 elements here, and you can use the periodic table. Sodium, magnesium, right? So sodium, magnesium, argon, phosphorus. You have sodium, magnesium, silicon, phosphorus, and argon. They are in the same row, the same period. So when you move from left to right, the size of them will decrease. So the biggest atom will be sodium and then magnesium. And so the correct answer is this one. Okay, it's about the first ionization energy. Strontium, potassium, rubidium, and calcium. Here, potassium, calcium, strontium, and rubidium. To compare more than 2 electrons, the first thing you can compare is those in the same row or in the same column. So let's take potassium and rubidium. We know that because they are in the same column, potassium will have higher ionization energy, and similarly for calcium, it will have higher ionization energy than strontium. And then we compare potassium and calcium. They are in the same row, so calcium will have higher higher ionization energy than potassium. So the correct answer here is calcium. Okay, atomic radius: selenium, arsenic, tellurium, and antimony. Here, antimony, tellurium, selenium, and arsenic. We can we can see that this question is very similar to the one about comparing these 4 elements. So the question is about largest atomic radius. So arsenic is higher than selenium, and antimony will be the biggest, right? Yes, antimony will be the biggest here. We have 2 very good students here. I think they have all questions answered right here. Okay, let's see. Um, the most electronegative rubidium, sulfur, silicon, and chlorine. This is rubidium in the 1A group, sulfur, chlorine, and silicon. Silicon, sulfur, and chlorine are in the same row, so chlorine will have highest electronegativity. And then we compare chlorine with rubidium. Rubidium will have smaller electronegativity than sodium, and sodium is smaller than chlorine. So chlorine is the correct answer. It is the most electronegative in this series. The smallest diameter or the smallest size. Oxygen 2 minus, chlorine minus, fluorine minus, and bromine minus. You can recognize that fluorine, chlorine, and bromium are in the same column, the same group. And fluorine is smaller than chlorine. Chlorine is smaller than bromium. So fluorine minus will be the smallest. Will be smaller than chlorine minus and bromine minus. And then we compare fluorine minus and oxygen 2 minus. They are isoelectronic ions, as we have talked about this in one of the last questions. So they are isoelectronic ions. Fluorine has higher nuclear charge, so fluorine will be smaller than oxygen 2 minus. So the correct answer here is fluorine minus. This question is not correct. No, this answer is not correct. The correct answer here is fluorine minus. Um, yes, it's not correct. Okay, so this is an error. An error. Remember that fluorine minus is smallest here. Okay, which group contain only non-metal? 2, 6, 7, 8. 2A are metals. 2A elements are metals. So for 6A, 7A, and 8A, you can see that when you go down a group, uh, the metallic character will increase. And the correct answer here is noble gases, because all of them are noble gas, or 8A, because noble gas are non-metals. Some of you will ask, how about 7A, halogens? They are also non-metals only. Yes, that's correct, that fluorine, chlorine, bromium, iodine are non-metals. But astatine has some metallic characteristic. So astatine is a metal, it's not non-metal. So 7A is not correct here. Oh, so I have finished this game, this challenge. And I have explained all the question here. I hope that yes, there was one error, one question not correct.